Duiker. Yeah.
Hello, everybody. My name is Dan. I am the head of developer relations here at Scaleway. Thank you so much for joining us on another Scaleway sessions. We had a lot of fun previous weeks, a lot of fun last week. We had the Ask Dr. Cube session. That was really, really good times. We are continuing on our trend as we were all throughout the month of March, talking about Kubernetes, talking about containers, talking about all that good stuff. And today we have another special guest, super, super stoked to invite Marc Duiker on to talk about some really cool stuff. I'm going to let him do all his introductions and whatnot, okay, in just a brief moment. But of course, I'm joined by Marc. I'm joined also by Diego here at Scaleway. Diego, as always, is our man behind the scenes, managing the stream, pressing the buttons, and occasionally hitting the soundboard. Because, everybody likes to sound like a radio jockey now and again. So once again, thank you so much for joining us. We really appreciate everybody that comes and hangs out with us on Twitch, hangs out with us in the community Slack, hangs out with us on YouTube, pings us on Twitter, tells us that they like the sessions. We're really starting to gain some momentum with these sessions. We're starting to fall into a bit of a groove now where we're kind of just hanging out on Friday afternoons. We've tried streaming in a couple of different times a day. And I mean, if you know anything about Twitch, sometimes a day are better than others, but also just, for us too. It's fun at the end of the week. Just hang out, relax a little bit, right? Unwind and hack around with some stuff. So thank you so much again for everybody who's been following us and interacting with us. Super, super appreciate it. All right.
Yeah, and also let us know if Friday afternoons work for you. Maybe Monday mornings are better because you need some lift up or something. Let us know.
Absolutely. Yeah, we're not, married to the idea of Friday afternoon. If there is a better time for us to be streaming that works for you, let us know because you're the only person that matters. All right. Enough for me. I'm actually going to hopefully let Marc introduce himself, a little bit about who you are, what you
Mm-hmm.
do. Please don't leave out the 8-bit art part because I love that
Oh
part,
yeah,
and
definitely.
a
Yeah.
little bit about what we're going to be taking a look at today.
Yes, excellent. Thanks for the introduction. I love the energy, by the way. It's super good. It feels good already. Yeah, maybe I need this on Monday morning as well. Maybe you can do both. I don't know. So hi everyone, I'm Marc
See?
Duiker. I'm a developer advocate for Diagrid, and there we help developers to build and run large-scale systems, distributed systems based on open source technology such as Dapr, and that's also the topic of today. But before I dive into that, yeah, I'm quite active in the community. I've done a lot of serverless stuff over the last couple of years, so if people probably know me from somewhere, it's probably for my Azure Function stuff, a lot of things related to Azure. But yeah, Dan already hinted to it. I also still do a lot of pixel art drawing. Maybe you're using the VS Code editor, and there's an extension for that called the VS Code Pets. If you've never heard of it, definitely look that up because a lot of these virtual pets in that extension are made by me. It's a completely useless extension, but it's just a lot of fun having it around, especially if you do some demos. And yeah, that's what I do, like more like all kind of side projects. I like drawing, but specifically making like connection with technology is always fun. I also have prepared some slides that are also now in pixel art style. So yeah, I'm trying to combine the best of both worlds there. And yeah, what will we do today? I was looking into running Dapr on several different Kubernetes providers. So Dapr is built on a sidecar model. I will explain a bit more with some slides later. But I recently did a Dapr on AKS one, so Azure specific. But I thought it could also be nice if you can run Dapr on Scaleway. So that's what we are
Amazing. Yeah.
doing now.
How was it? How
It,
was the
it,
process?
the process was went quite well, to be honest. So it was pretty smooth because to be
Yeah,
honest,
you can be honest.
no, yeah,
We
no,
can take
but
it.
seriously, but because I'm not very well known or versed in the whole cloud native Kubernetes space, so I still have quite some learning to do. But especially indeed with all of the documentation that was there, I was able to follow the documentation, and I'm using the CLI, the Scaleway CLI for these things, and that worked pretty well out of the box. So no surprises there. So yeah, it was pretty straightforward. Need to get up with Kubernetes on Scaleway and to have this Dapr workload running on Scaleway.
Great, great.
Looking forward
If
to
the
demonstrate
process
that.
is straightforward, if there's nothing that comes to mind, then that's a positive experience, right?
Yeah,
It's
exactly.
smooth.
Exactly. Yeah, indeed. Yeah, because sometimes something might not be very well documented, or yeah, then there's of course always a difference in, and maybe someone who have written the documentation is maybe a different like skill set than the one who's reading documentation. But yeah, in this case, it felt like a good match, and I could get up and running with the CLI and create a cluster and so on and so on. But yeah.
Amazing.
But I think maybe we should first talk about Dapr itself
Yes.
before we actually start deploying it, because otherwise you'll probably know
Yeah,
idea
yeah.
what
So
we're
we
talking
know
about.
what we hope people know what's Kubernetes because we've invested this whole month of March talking about Kubernetes.
Exactly.
So
Yeah.
now
So that should be
we are adding
more
a
or
new
less clear.
piece.
Yeah, exactly. Yeah, that's nice. Yeah, you can keep extending it, and well, yeah. You've
Exactly.
also probably talked about that whole CNCF landscape, right? With that huge map of all the different applications on there. That map still looks quite scary to me, because there are like
Yeah,
hundreds and hundreds of logos on there. So
yeah, and they
yeah,
keep
yeah.
adding logos every time.
So I don't hope that I ever have to learn all of these logos and what they mean. But
Mm.
yeah, I am adding just one element to it, and that's Dapr. Let me start with
All right.
sharing my screen though. I can share some slides. Let's start this. All right.
There we go.
So yeah, this I think is a typical thing that development teams are asked to build these days. It's usually like distributed applications. It usually involves like microservices having just one very specific task, but these things all have to communicate with each other, and it also needs to communicate with other parts in the outside world or to databases and pub/sub systems and so on. And I think that's quite tricky for developers to do this right, because of course you need to call your services in a secure way, and in case these calls fail, you want to do some retrying, for instance, and how can you actually make a call to a server, right? So how can you discover one service to another? How do you orchestrate your business logic? So I think there are a lot of like cross-cutting concerns when it comes to building these distributed systems. And luckily there are some solutions for that, and one of these solutions is called Dapr. It means the Distributed Application Runtime. And it's like an event-driven portable runtime for building distributed applications across cloud and edge. And well, what do I mean with that? It runs on almost any cloud where you can run Kubernetes. So these are all very big and well-known ones. I shall update this one and also add Scaleway now, because it definitely runs there as well. But it can also run on virtual physical machines. So it really runs everywhere, so that's great. And what I really like about Dapr is it's really a developer-oriented solution. So it really speeds up your microservice development because it offers like a different set of APIs. And these APIs are spread across different categories, and these are all the categories out there. So it's quite convenient with Dapr to do like service-to-service invocation, or to use a state store, or to use a publish pub/sub messaging. You can do like input and output bindings. There's observability built in. There you can also use the actor pattern. You can use different secret stores. You can use different configuration stores. And there's also some like different architectural type patterns that you can solve with it, like distributed lock. And with the latest release 1.10, you can even run long-running workflows, which is really powerful. So it's quite a broad spectrum that you can do with Dapr, but like I said, it's really like developer focused. So how does it work? Well, yeah,
All that from Dapr.
all that from Dapr. Yeah, exactly. Yeah, and those are just like that's just the surface area. But now we're getting a bit under the hood and how it works and how everything is implemented.
Right.
So with that, I hope to sketch a bit what the extent is, what you can do with it.
So awesome. I'm sold.
Already? Oh my God.
Yeah,
Excellent.
if you can
Excellent.
do all that from one single app, I'm sold.
Yeah,
Tell me more.
exactly. Yeah, just with one framework. Yeah, it's really amazing. Seriously.
Yeah.
So how does it work? Well, your application talks with a Dapr sidecar. So the Dapr runs in the sidecar. So it's a separate process running there, and you interact with it with an API. And well, you can interact with it via HTTP or gRPC as follows. So in case you want to invoke some kind of a different method, you can use the invoke path, or in case you want to retrieve a state, or in case you want to publish a message, or when you want to get a secret or something, or when you start a workflow. So this is like a very new, it's still an alpha. So yeah, you can do all these things with the HTTP or gRPC protocols. But there are also client SDKs, and these are much easier to use. So I would definitely suggest to use these client SDKs. There are more than these, but these are the most used ones. But in case maybe some people are really quite strict in the kind of dependencies they take on in their applications. So maybe you don't want to take on a dependency to Dapr in your application. So then you can use the straight HTTP gRPC ones. But if you're okay with the dependency, then this would be the way.
So if we're not okay with the dependency, for example, what would be, I assume there's going to have to be some sort of authentication mechanism. There's got to be some sort of way of going, hey, I have a token, or hey, I have some way of doing that. What types of options are available there?
Well, yeah. So the communication between the services is done between these Dapr sidecars there. So and that goes via MTLS. But you can also connect like any OpenID provider to that as well. So that's quite some options there. But good question. Yeah.
Thanks.
So about the Dapr project itself, it's like a CNCF project, submitted in 21. It's currently in incubation and maturity level, and it's actually the 10th largest CNCF project, which is just quite cool because there are like hundreds of them, right? So it's pretty insane. And yeah, we're doing quite well on the community as well. So we have lots of contributors, a lot of Discord members. So that's also now my job to take care of that. And there's lots of contributions from quite big organizations. So it's really very cool to see that a lot of big organizations are now indeed contributing quite significantly to Dapr to make it sure that it can run across all these different clouds. All right, so now this is what I think is the very cool part. So I mentioned that these are all like the building blocks, right? So these are all the APIs, and you can think of all these APIs like they're like an interface, right? So your application will talk to this interface, but of course, if you want to save some state or retrieve some state, there has to be like a state store behind it, right? So that there's some actual thing involved that does something with state. So these things are called components. And for each of these building blocks, there are like dozens of implementations of it. And that's what makes it possible to have it running either on AWS or on Azure or GCP or Scaleway. So that's actually quite cool. So for each of these building blocks, there are like a lot of different implementations. And those are swappable. So I'll show that in a second. This also shows already which APIs are quite mature and quite stable, right? Because those have a lot of different implementations already, but the configuration and distributed log and workflow ones are quite new, so they don't have that many implementations yet. And this is just some examples, right? Because I think the state management is the one which has the most components. So I think in total there are like 110 components out of the box that you can use across all these APIs. So that's really cool.
I'm going to have to ask the obvious question here, which is if I've got a thing that's not on this list, can I make my own component?
Exactly. Yeah, that is called a pluggable component. Yeah, you can make your own. Yeah, and you can make it yourself. But I mean, in case you might want to connect to some really kind of obscure internal system that nobody might know about, that's totally fine, right? You can create your own component, keep it private, and use that. So yeah, totally possible. So some more state stores from the docs. These are more of the open source ones. So I'm gonna explain with just I think 3 slides how it works, and then that will be at the end of the slides. But I think this is nice to see. So let's say your application wants to store something in a NoSQL database, and in this case it's a Cosmos DB one from Azure. So before Dapr, you would import the Cosmos DB API, right? You would import a package, so you can use the API to communicate to Cosmos DB. But in this case, we're talking to the Dapr sidecar. So we are using the Dapr API to save state or get some state. And your application has no idea whatsoever about Cosmos DB. But Dapr needs to know, right? Because in the end, Dapr will make sure that your data lands somewhere. And so there's a YAML file involved. And I'm always saying okay, I'm sorry there's more YAML involved, because I think there's too much YAML in the world already. But yeah, it's a kind of unnecessary evil when you work with Kubernetes, I think. But this YAML file contains like an ID. That's like a component ID. That's my storage string. That's the only thing your app needs to know. And the spec then also contains a certain type and some metadata like connection strings or users or whatever. And this is how Dapr knows, okay, I need to actually go to the specific Cosmos DB store to get my data or to store my data. So if you now want to switch the underlying database, which is totally doable, you only need to update this YAML file. So you keep the ID the same thing because your app refers to the ID, so your application code remains exactly the same, but only this YAML file changes and the specification changes. And if you deploy that, then your application will just happily continue and talk to a different database.
Well, you say it will continue to talk to a different database, but what if it's a different database engine?
Well, in this case, the Dapr API has some kind of a different abstraction, right? So in this case, the state management API assumes like a key value store. So you just have a key and a certain value, and that's the thing you can store. And all of the components that implement this state store interface, they can all deal with this. So in case you need some kind of a richer or more specific state store experience. So for instance, I know the Cosmos DB one has quite some exotic and specific APIs. Those are not available in Dapr. So it's a bit of a trade-off. Do you want to go more native to that state store and want to make full use of their API, which is maybe more performant or maybe allows you to very special queries or whatever? Then still use the dedicated connection to Cosmos. But if that's not the most important thing, then you can use Dapr and use a more common set of APIs. And then everything is treated like a key value store.
But I mean, everything's a key value store if you squint hard enough, right? I mean,
yes, true. True. Yeah. So it's really about what's your goal, right? I mean, if you indeed want to easily create some kind of, or easily want to store and retrieve some state somewhere, and you don't really care where it is, then I think Dapr might be useful for you because it can run anywhere. But if you really want to use a very specific solution, then you probably also want to use that specific API, so you can make full use of that state solution. And then probably the Dapr API doesn't make sense for you. Yeah. What I like about this is, for instance, locally, you can have your local instance of Redis up and running, or you can even choose like a in-memory store. So when you're just doing dev or test locally, you'll have your own YAML, which you can have a very tight inner dev development loop. But once you go to acceptance or production, then you switch out the YAML file for your cloud-based storage.
We actually did something like this just a couple of weeks ago on stream. We were playing around with it's a sort of an Airtable clone called NoCoDB and deploying that and seeing and playing around. Nice. And when we just deploy that from the documentation, it implements a SQLite, right? So it's just got a file sitting on the file system, and then you make that available to the container, and it just loads it into memory, right? And we were like, well, what's going to happen when we want to use a real database? What's going to happen when we want to, put this in Kubernetes, and now there's going to be multiple SQLite files floating around. Technically, there's multiple nodes, right?
Exactly.
And we're just like, actually, we could just specify another database. in the interface, and we just did it, and then all of a sudden we just had it available to us, and we could just boop, import it all over, because at the end of the day, it's just SQL,
Yeah.
right?
Yeah, exactly. Yeah,
So this would be not dissimilar to that scenario where you were just going for, you're trying it out,
Yeah.
right? The hello world of
Yeah.
Dapr is where everybody begins, and we don't have to worry necessarily about, putting a large infrastructure in place with various databases and replication, and it passes, various eventual consistency tests and blah, blah, blah. For all we really need is just want to try it out.
Exactly.
We can just have that be in memory. We can play around with it. We can even put real data into it. And if we go, wait a minute, it works on my computer, let's put it into production.
Exactly. Yeah. Then the change is not as big as you might have thought or something, right? So that's really positive. Yeah.
Right.
Yeah.
All right, cool.
Yeah, and yeah, actually that usage that you mentioned, SQLite is also one of the components that you can use with this state store as well. So yeah, it could definitely be like swappable from that kind of perspective. Yeah. So yeah, I think this is really one of the very nice benefits of using Dapr, that there are so many components that you can use for these kind of things, and each release more components get added. That's very cool. Yeah. Okay. We don't have to go into this. I think.
Well, is Dapr a service mesh? I mean, yes or no? Perfect.
Great. Straight to the point. Love it.
Do you want to go into this? We could. Okay, let's make this a final slide. And so there's definitely an overlap, right? Because as soon as you mention sidecar, a lot of people will think, okay, this is probably then like a service mesh kind of a solution. But it's not exactly a service mesh, because a service mesh are usually quite related to network and infrastructure, right? So it also does like service-to-service discovery, but you can also do traffic or like A/B testing based on routes and stuff like that. But Dapr cannot do that. So Dapr is what it says on the slide. It's really like a developer-centric application for using all these building blocks and using all of these components, and then making it easier to switch from one thing to the other. That's what it's all about.
So it doesn't preclude the use of a service mesh.
No, they can work together. Yeah, there's lots of companies that use Dapr and Istio, for instance. So yeah, definitely. Yeah. Good call. All right. Shall we try it out?
Yeah, let's give it a go.
Are we ready?
Yeah. We can come back to these slides. By the way, this is delightful slides, right?
Oh, yeah.
For those of you who have maybe never seen, who have had the pleasure of seeing Marc do a presentation, don't follow him on Twitter, et cetera, just every single time, just a visual delight. So,
Thank you. Yeah.
Honestly,
I spent quite some time on this indeed. Yeah, so
it shows.
I gave the first session with this new slide deck, actually this week, on Monday. And this was the start slide. I have to still show you because it was like fully animated.
Oh, look at that! Oh my goodness! Oh, this is pro. We're hitting the big time there.
It was a lot of fun to make, but to make it, I use like a dedicated tool for pixel art. It's called A-Sprite. It's like a sort of a Photoshop light. You can do most of the things. It has layers and then all kinds of dedicated tools. So that's what you use for all the animations. We then just copy paste them over in PowerPoint.
That's cool.
All right, so we've got what appears to be some sort of code repository.
Yes, exactly.
On the screen right now.
Exactly. Do you need to enlarge this, or is it big enough?
Right. So, you know what? It's never big enough is the complaint. Right.
Exactly. Okay. Here we go.
There is a URL here. Would it be possible for someone, possibly some sort of behind-the-scenes stream manager, to share this URL with those of us watching the stream?
Yeah, it's already there.
It's already there. My goodness.
Oh wow, so smooth.
Excellent.
Amazing. All right. Yeah. So this is what I created over the last couple of days. It's actually based on the actual Dapr documentation. Let me quickly just show the Dapr docs. So this is the Dapr docs. It's really extensive, and it also has like a tutorial called Hello World Kubernetes. So this is not the exact thing that we're running, but it is heavily inspired because this then that doesn't assume any specific cloud-based Kubernetes. It just mentions, okay, just use a Kubernetes cluster somewhere, or either local or in the cloud. And then it mentions, okay, we also need a state store, so just figure out how to get a state store somewhere. So I've condensed all that information into this repo. And what we'll do is we'll create a Scaleway Kubernetes cluster, and we'll install Dapr on it. We'll install Redis as the state store there, and we'll install or deploy 2 applications. Okay, let me make it.
Now, the question before we dive into all of this is do you expect this to work? And I don't mean that as as I doubt your abilities.
You should.
But here on the Scaleway sessions, when we dive into things, there's no particular expectation that we're going to succeed.
And
Yeah,
that's
so
okay.
I tried this twice, and twice it worked. But yeah, I mean, and any success you had in the past is not a guarantee for success in the future.
Fair enough.
Right? So I don't know.
It's a live demo.
Yeah,
Yeah.
exactly.
Something
Super.
will probably go wrong. So yeah.
Yeah.
All right, I'm excited. Let's do this thing.
Okay, so just to explain the demo, what we see here, okay, so this is us 3. So we're doing some commands, and we're going to install Dapr first, and we'll come back to this later. These are the 2 applications. So there's one node application that talks to a database, or Redis state store in this case. It does read and writes of order IDs. And as soon as this is up and running, we will invoke it with an HTTP call and see if it works. And if it works, or when it works, then we'll deploy this Python application, and that just runs in a loop and creates new orders, calling this pod. Okay. So what do we need for all this? I think probably most is quite well known in case we're using Scaleway. So we need an account, using the CLI. And if you run the init command of the CLI, you need to provide some API keys. So we also need that. I've already did it up front, so that's not what we're doing today, though. We need to have some Docker and Kubernetes related tools is there, but yeah, this of course is the big unknown for most of you. It's the Dapr CLI. That's also already installed on my machine, but all of these things link to pages that explain well how to install these things. And I'm using VS Code with the REST client extension to actually make some HTTP calls to that node application. All right. So the reason I chose for the CLI versus the portal is you usually in these things work quite well via the portal, but I always want to see, okay, well, what's the experience via the CLI then, right? And the reason I like CLI is because it's quite easy to all mention these CLI commands in documentation, because it's always hard to make screenshots or do animations of screen, stuff like that. So that's why I prefer to actually go the CLI route, because then we can do stuff like this and
it's great when you have to try to describe how to click on things in text. Exactly. How far do you want to go into detail there? Okay, now take your mouse and move it roughly 4 centimeters to the left.
Take your mouse and move it up to the screen.
I honestly, literally had to do that specifically when I was working several years ago as a community manager for Microsoft Answers forum. So it's quite old.
Wow.
It was meant for non-technical users, like really not technical users. So please put your finger on top of your mouse. Now press lightly on that finger twice with a short delay of blah, 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 blah.
That sounds insane. Okay.
I try to tell somebody who's not familiar with this stuff how to hover, right? Like hover and wait for the tooltip to appear.
Ooh, yeah.
Yeah.
Good
times.
Tricky. That is tricky.
All right.
Okay. I'm going over to VS Code because I have the GitHub repo cloned locally. And this is the same markdown we were looking at earlier. This is exactly the same thing. Let me first prove that Scaleway is up and running. So scw is the command for Scaleway.
That is, by the way, for those of you who have not had a chance to check out our command line tooling yet, scw is just exactly what it seems like. It is the command line tool that we release as open source. You can go check out all the code. We did a whole thread about it actually on the Scaleway_devs Twitter account a couple months ago. And it is just like you would expect, programmatic, command line access. Well, it could be programmatic, right? You could build that in the shell.
Yeah, exactly. Yeah.
Exactly. Yeah. And that's just for managing Scaleway resources, just like you would expect. So if you're not using it and you're like, boy, I wish I didn't have to point and click to make things go. Well, you don't. Check out scw.
Exactly. Yeah, and it's linked here. Scaleway CLI, where to install it, download it, etc. So definitely. Yeah. And then the first command you should do is like scw init, and then it will ask you for some IDs, project IDs, and API keys, and so forth. But that part I already did. I'm just checking my current information, which gives back my context. So these are all the settings that the Scaleway CLI now knows. And I think the only change I made here was the default region, because I think the default region is France. And I changed that to the Netherlands, Amsterdam, because that's closest to me.
Very good.
Good choice.
Yeah, good choice. Good choice.
Yeah, and it's actually quite because I think you can do like Scaleway, and I think it's config set. And this then the help command. Oh, config. Yeah, no, that doesn't exist. Config. So this is the syntax to actually change these parameters. For changing the region, right? You could change your default region to NLMs in this case.
It's all pretty straightforward. You can, of course, use the command line tool to modify the configuration. You can also modify the configuration file directly if you prefer, if using some sort of configuration management, or if you're very, very fancy and you're syncing your shell preferences and profiles across multiple machines. That can be very, very handy.
Good point. Yeah. Okay, make this one bigger as well. Okay.
You have a really nice looking prompt, by the way. The colors and like the little graphical elements there. That's really.
Yeah, it's So I'm on Windows. I'm using PowerShell, and this is the Oh My Posh, which is like very comparable to Oh My Shesh.
Looks good.
Okay, so the first thing I am going to do now is create a Scaleway Kubernetes cluster. So I'm going to do a lot of copy pasting and then explain what it should do. Let me clear this actually a bit, so we don't have a lot of clutter. All right, so scw and then Kubernetes, K8s, and then we want to do something with a cluster. We're going to create one, then we have to specify a name. So in this case, this is the name of our cluster. Then we have to set the pool size. So in this case, we want 2 pools. I still have to look up why I have to do like pools dot and then an index and then size. I have to check the CLI documentation for that.
Just because it's JSON all the way down, right? I mean.
It starts to make sense. Yeah, exactly. Yeah, and then I'm also specifying a node type. So I'm choosing like a very small machine type. So it's the Play 2 Nano, and I have to specify a pool name. And that's it. So let's run this. So it immediately gives back quite some information, but the most important thing to see is status running creating. So it's now busy creating the cluster. And well, we also have a browser here somewhere. It should also show this. Okay, so it's creating it. Perfect. Let's go back to VS Code. But yeah, before we can continue, we need to make sure that it's actually ready. So let's actually do this list of clusters. So just gonna ask now, okay, what clusters are existing now? Okay, it's still creating. So we still have to wait a bit.
So we're waiting for that to fire up. Because, it's the cloud. Sometimes things happen like this, and sometimes it takes a couple seconds. That's fine, right? I do have some questions that aren't related to Dapr, if you'll indulge me.
Sure.
And my first question is, and I apologize if this is the obvious one, being a professional developer in the Windows world, what's that like? I have not used a Windows desktop machine as my primary machine, I think since like Windows 98.
Right. Okay. Yeah, it probably very much depends on what you do, right? Because some things are very compatible with Windows, while others might not be.
Sure.
So for the work that I've been doing most of the time, it was always perfect. But I've been doing a lot of Microsoft related stack, right? So then it actually makes sense to also have a Windows machine. But yeah, especially since there was like a .NET Core, then all of the stuff runs anywhere. So since that moment, it doesn't really matter that much if you use like a Windows machine or like a Linux or or Mac. The only thing that is still maybe not completely feature complete is some of the developer tooling. And so, for instance, VS Code runs anywhere. So that's also my favorite tool right now because I have a Mac and I have this Windows machine. So I switch from time to time. But for instance, like the full Visual Studio Code, for instance, the Mac version is not the same as the Windows version. So it's not feature complete, the Mac version. So there's definitely a difference there.
I get that's surprising. Well, maybe not that surprising. Now that I think about it.
Exactly. Yeah. Because it definitely had the full history of him when you do lots of Windows development and also maybe Windows desktop development. And then you probably need a Windows machine anyway. So the development of the Mac version was then just a bit later.
Yeah, I mean, if you're using a Microsoft-centric programming language to develop Microsoft-centric software for Microsoft-centric environments used by Microsoft-centric end users. Why rock the boat, right? That makes sense.
There's mono.
Yeah. No, but that makes sense. And as you said at the outset, a lot of like virtual development environments, tools like Gitpod, where you're basically just opening up a browser, and as long as you have a browser and a keyboard and a monitor, your development environment is going to be consistent.
Yeah, actually.
So.
These days, it doesn't matter that much anymore what you run. It almost is like the same experience everywhere. But sometimes because sometimes I have like the opposite, right? Because sometimes the instructions are only there for a Mac, and then I have to figure out how to run it on the Windows, right? So, it's definitely like whenever you do your documentation, make sure you do it for multiple OSs, so you serve everyone.
Yeah, this is super important. We've got one of the open source projects I'm involved in. We had the build pipeline. The build pipeline ran tests just like it's supposed to. Yeah. And it ran them on on Linux and ran them in an OS X environment. And we were like, great, we've done the only two environments that exist. Right?
Yeah.
Yeah, it turns out no. Turns out
ouch.
Yeah. So anyway,
that's tricky, but it also like massively expands all of the effort you have to put in, right? I mean, if you do it for double the OSs or like different versions, and it's also a lot of effort. I do understand that, but it can hurt the experience in it. Yeah. Especially when it comes to the only very annoying thing that I find really excruciatingly really annoying is like the difference in paths between Windows machines and Linux or Mac OS, right? Because you have the forward slashes versus the backwards.
Yeah.
That's always messes me up.
Every time.
Yeah. And then that was really
with the Windows terminal, that now that you can have multiple terminals and just tap into a different one. So that's an improvement. Then when you're changing directories, then you need to change the mindset or backward slash or forward slash.
Yeah, exactly.
And I think actually that was one of the big changes, Windows terminal, and also having Linux. Windows subsystem for Linux.
WSL, exactly. WSL is really excellent.
Those two have been the greatest improvements for developers, I think, in the Windows in the last few years.
They've come a really long way. Yeah, and indeed, especially tooling-wise, if something doesn't run natively on Windows, you just run it on WSL. So that's perfect. Yeah, cool stuff. But I also like the Windows terminal. It's super nice.
Yeah, we were just chatting in the chat. about the fact that you're using a nice bright white screen here. So I know when I'm doing some demos and stuff and I'm showing off code and whatnot, and I've gotten this criticism, why aren't you using dark mode? Why aren't you using dark mode? And I got to tell you, when I'm developing on my own and I'm the only one staring at the screen, it's in dark mode. But when I'm showing things off, I'm doing this as well. I'm putting it into light mode. I don't have a good reason for that.
For me, it comes from the times when you have the projectors, like the old school projectors, and the contrast with the white theme is better.
It's true.
So that's why I just switch.
It's true. If you're in a brightly lit space and you're using a mediocre projector, trying to have tiny little letters on a black background, it's impossible.
Yeah, exactly. Yeah,
that's a good point.
Yeah,
all right, I think we have our resources up here, right?
Exactly. Yeah. It's ready. So
it's ready right there.
Excellent. So now we have to make sure that we get this information into our local kubeconfig, and we can do that with this command. But we do need our cluster ID, and luckily that is mentioned right here. Okay, so this will make sure that we can use our local context whenever we want to interact with this Kubernetes cluster. So if we want to use like a kubectl or Helm and so on, then they all know that we need to talk to this Kubernetes cluster. All right, so that's now there. That's perfect. And so now we can use one of the typical Kubernetes tools, kubectl, to actually give us back some information about the cluster.
All right, so I was supposed to say, I wonder how Marc's going to pronounce this word.
Yeah, I'm doing CTL, but
CTL?
Tell me about all the variations you've heard. I'm also curious.
You're asking for a full talk over here.
Yeah, literally did a whole presentation at Kubernetes Community Day, France, just a couple weeks ago on how to pronounce
about
this.
the pronunciation. Oh, that's brilliant. Oh, I love it. Yeah, it was like kubectl or cuddle even, or
Quebec Tulle.
Quebec Tulle? Oh wow, that sounds really fancy.
Yeah,
I like that. Wow.
Yeah.
Oh, that sounds very good.
Yeah, there you go.
Yeah. I mean, yeah, but what do people expect, right? If you name something like this, I mean, you're just asking for all kinds of different interpretations. I mean, yeah. I mean, I'm also very curious what people will say about this. I mean, I don't know.
So we see here we've got our cluster info. It says Kubernetes control plane is running. We can see that it's running. We can actually hit that up in a browser if we wanted to. We don't have to do that right now. But we can actually hit that up. We're going to see the standard sort of web interface that you're going to get with that. We also see the core DNS is running. Of course, DNS is very, very important in the world of Kubernetes. As far as we know right now, everything is working like we expect, right? Like nothing here looks weird to you.
Exactly. Yeah, there is indeed a cluster. There should also be like two nodes. So that's actually the next thing that you check if the nodes are also there. So again, the CLI also offers some info for that. Let's copy paste it from here again. So now I'm going to list the nodes in this cluster. And our two nodes are there. Yeah, perfect. I mean, you can also do the kubectl get nodes. It will give you the same thing.
Perfect.
Yeah, so we have the cluster, we have nodes, but apart from that, there's nothing much on there. I mean, kubectl. I mean, there are no paths yet, unless we check all of the paths and all of the namespaces, because then we have all of the Kubernetes specific things going on there. But there are no paths yet that run Dapr or our applications or whatever, or Redis, so that's not there yet. So now it's time to install Dapr, and then I will explain what it will install there. So for this to work, you need to. Oh, I don't want to do this. For this to work, you need to have the Dapr CLI installed. So the link was in the prerequisites. You need to run the init command and then provide this dash Kubernetes or -k to make sure it talks to your Kubernetes cluster, because otherwise you can also use CLI to do stuff things locally. So with the dash Kubernetes, it will use the context to actually do the installation in your Kubernetes cluster, and then we use the dash wait to actually make sure that everything is there before we continue. This is not the only way how to install Dapr on Kubernetes. This is also mentioned you can also use Helm charts, for instance. It depends a bit on the cloud provider. So there are also some cloud provider specific installations. So for instance, for AKS, there's also an extension you can use. So yeah.
Now, in that particular instance, do you have to use the extension, or could you use Helm, or could you deploy it directly this way?
Yeah, you choose, but it's usually the case when whatever you choose, you have to stick with using it, right? So if you choose the extension, then keep using the extension, or if you use Helm charts, keep using Helm charts. So don't start mixing and matching.
Don't cross the streams, basically.
Over time, yeah, exactly.
Yeah.
Indeed.
What would be the danger in your estimation of that? Maybe danger is a strong word, but what's the difficulty level there?
I think it's very likely that you get some configuration drift if you start mixing and matching these things, right? Because your Helm charts are, of course, in Git somewhere, but it's your extension and the commands that you run. So those are like CLI commands, and maybe you do them by hand, or maybe those are also in Git, but maybe they're not the same as the Helm chart. So it's just very likely that you'll have some maybe unexpected differences. So that's probably the main reason. Okay, so it's done, but I didn't have the time yet to explain this. So it's now installed a couple of pods, and all of these pods have a service running. There are actually 5 pods we'll see soon. But there's an operator, and that will interact with all of the state stores. So in case you need to upgrade a state store or switch it, this operator will take care of that. There's the injector service. So whenever you deploy an application, it will inject the Dapr sidecar. And there's a Sentry service which helps you with the service-to-service MTLS connections and authentication. Let's scroll back. So we can check the status now of the Dapr control plane, because that's what we just installed. So here are the services that are mentioned. I didn't mention the dashboard yet. I'll show that a bit later. There's also a thing called the placement server. I won't go into that now, but if you want to use the actor model, which is quite popular if you want to do some IoT related stuff, then this placement server is used to determine which pods run which actors. All right, so now we have a cluster, we have Dapr there. So the next thing that we can do is the state store. So just using some different tools. So now actually going to use Helm to get a Helm chart to offer a Redis distribution from Bitnami.
So we are going to cross the streams.
Well, in this case, what I said before was about Dapr. So if you manage your Dapr control plane, or if you manage Dapr via the CLI, then keep doing that. But if you want to manage the Dapr control plane via Helm, just keep doing that. So in this case, I'm indeed doing Redis via Helm, but not Dapr via Helm, which might not make a lot of sense, because usually you'll choose one way and do everything via that way. But you should stick for one component. In this case, I mean Dapr. You should stick to the tool that you use to install Dapr and to manage Dapr.
That makes sense.
So I'm going to copy paste this, but I already have this Helm repo. So it's going to say, okay, it already exists. Fine.
What would have happened there?
It would have got the Helm chart for Bitnami and downloaded it to my machine, so I can now start actually applying it. So, but I already have it, so that's why so I'm now checking if there are any changes. So I already had a reference to this Bitnami distribution of this Helm chart, but maybe there are differences. I'm now going to check, are there any new versions I can use? So that's this. All right. So it will always mention successfully got an update. So I'm not sure if there is always an update, but it always says this. So
can you run it again right now?
Oh yeah, let's do that. Yeah.
So it's unlikely that there was an update.
Exactly, I think so too.
Right there.
I think so too. Yeah.
Yeah.
It's a bit misleading, eh? Yeah.
What if every time someone does a Helm repo update, it updates a counter?
And that's the update, yeah.
That's exactly.
Yeah, I find this a bit silly, to be honest. But yeah. So what I'm now going to do, I'm going to install this. I'm clicking on the Markdown file, and that's not a good thing. So I'm now going to install.
Development on Windows, eh?
Yeah, exactly. Oh my God, it'll do the same thing on Mac. So I'm now going to install the Redis, and I'm actually going to specify a specific version of Redis, and that's to make sure it's compatible with the features that Dapr uses. Okay. So this will install it. We get back a lot of information about Redis, how to connect to it, etc., etc. But for this demo, everything is wired up already, so we don't have to actually copy paste all kinds of URLs or ports, or we don't have to worry about this. Luckily,
that would be a good time to hard code a bunch of passwords and then put them into a GitHub repo somewhere, I think, right?
Yeah, exactly. Yeah.
Yeah. Okay. Great.
Yeah.
Just confirming.
All right. So we're going to check the pods in our default namespace, and that should have some. Actually, that should have some Redis pods now. So there's a master running. There's the first replica is also running, but it will create some more replicas for us. So that's good. We don't have to wait for this because there will be one more. But that's totally fine. The next thing we'll do is we will apply the custom resource definition for our state store. So this is something specific for Dapr. So let's actually open this file. So under resources, there's this Redis YAML, and this is a custom resource definition of type component. So that's an entity within the Dapr world. This is the name of the ID that we're using. So our application is using state store as an identifier of this component, and this is then the definition that Redis is used. And if we scroll a bit further, then we see some secrets being mentioned. In this case, we're also using a secret store. So anything underneath this type line that defines the exact type of this component contains some metadata about Redis, how to connect to it or how to interact with it.
That makes sense.
So we're using kubectl again to apply this configuration. So Dapr, so the Dapr control plane knows that we are using this state store, and whenever our application mentions state store, then it will look up this configuration and knows that Redis will be used. All right, so that's created. Cool. So now we're ready to deploy our first application. That's the Node application. Let me expand this. So this is now in the Node folder, and we have an app.js here. Let's make this a bit bigger. Well, there's not too much in there that's of great importance. I mean, there are some like the default ports in case the port is not set and so on. But this is very important, the state store name. So this corresponds with what we saw in the YAML file. And in this case, so this is like a JavaScript, but we're not using the JavaScript Dapr SDK, right? So we're not importing anything from Dapr. So that means we're using the plain HTTP API. So this is the actual URL that we'll be calling. We will always be calling like localhost because it's a sidecar to a specific Dapr port, a implementation version of this state store. It's the state API, and then it's the state store name, which in this case is also state store. It's probably not the best name to identify it, but okay. Then there's a get API. So when you do the /order, it will retrieve this order key and it will get back the latest value. In this case, for storing order IDs, I'll show that in a second. It's a key value store, and we'll just be retrieving the latest order that's inserted.
I mean, this is just your standard issue route, right?
Yeah, exactly. Yeah, indeed.
Yeah, for sure.
So it's just we're just fetching this URL and this order endpoint, and then we need the response will be just whatever we retrieved from the state store.
You can see right away though how someone might come up with that question, which is this a service mesh? Right? Because as soon as we start talking about routes, as soon as we start talking about application logic, as soon as we start talking about, okay, we're going to analyze the HTTP request, and based on the contents of that request, we're going to do this, we're going to do that. We're actually maybe going to implement logic before the HTTP request even gets to the ultimate endpoint. We might be catching it. We might be doing things with it. So that question of is this a service mesh?
Yeah, that's definitely part of the overlap, right? So it definitely does stuff with requests and stuff, and it also inspect headers and things like that. So there's definitely there's the overlap indeed, and also when it comes to metrics and end-to-end tracing, so that's also in Dapr and also in any particular service mesh. So yeah, that's definitely overlap there. Yeah.
Okay.
And then there's this new order endpoint. So when we do a post to new order, we'll actually we'll store something in the state store. So there should be like a payload with an order ID in there, and then we prepare like a new key value pair with that state. So the key is always order, and the data is then the number of this order ID. Anything else in here? No, because again, we do a fetch of this state URL, but now we do a post. We stringify the state, and it's JSON payload, so that's why we set this header.
So this is really cool here. You're basically just showing us how to, write our own Amazon.com. Super appreciate that. Turns out it's not that hard. Turns out it's just, click to add order, right?
Yeah, exactly.
That's very straightforward.
No, it's very light on the code side, which I think is good, right? Because the code is not the most important thing here, I think. All right. Let's apply this one now. Oh, I didn't show you the YAML file itself. So the YAML file, that's under resources. So it contains two things. So there's a service here. And so we can actually call into the Node application, and there is the actual deployment of this Node app, and that actually refers to an image that will be downloaded, right? So which is basically the same as what I just shown you, but I'm not making an image here and uploading it and blah blah. So that's already there. And here we can see that Dapr is enabled. Dapr needs an app ID. Because the other application that I'll show soon, the Python one, will refer to this app ID, Node app.
But I mean, that was just under the annotations section in any case, right? So that's not necessarily some weirdo custom data. That's just annotation.
Yeah, exactly. Just identifying the types and specifications of the stuff that you're going to deploy. Yeah.
Right.
Okay. Before we call it, let's make sure it's actually rolled out. We do it with the kubectl rollout status and then the identifier. So it's not just rolled out, so now it's waiting to be deployed. Okay, so now the application is there, perfect. Of course, we need to know how to call it. And if you run the get service node app, because that was the ID, we will now get the external IP. So that's what we now can use to make our request. So I'm using the REST client in VS Code. I'm not sure if anyone familiar with that, but with the REST client you can make this .http files or .rest files, and you can make your requests as plain text in here. So you do get and URL, or you can do post and specify a header and either refer to a file that contains your payload or do your JSON payload just plain in here. And you can use variables as well. So I have a variable called external IP. So I'm gonna paste it in here. So now there's this command that lights up now. It's called send request. So I can click that, and then on the right, the output will appear. So I'm going to now make a request to the /ports. Oh, I didn't show you that endpoint, but that will return the Dapr ports which are in use. So this is more like a sanity check from, is our application Daprized? Is the application available with Dapr ports? Okay, so this is a response. I get back a 200 OK, and the payload contains the Dapr ports.
That's actually super cool. I did not know that was a thing in VS Code.
Yeah, well, it is like a separate extension, right? So it's called the REST client.
So here I am doing curl request.
Well, yeah, so the documentation actually mentions a curl request because that's what most of the people use. But yeah, I'm actually quite fond of this REST client, and yeah, you can also like easily.
That's really nice. It's nice and clean, right? Like you could just pop some stuff in there. You could put comments in there, right? Like,
exactly. Yeah. So these things are comments need, and if you do like multiple commands, you need to separate them with these 3 hashtags.
Yeah.
Yeah. So now,
there is a version it if you wanted to document it.
Yeah, and I see that's there. You can load in JSON. Just
exactly. Yeah, so there's this JSON file here, and we're going to need. So this will be our payload.
Well, that's all right, eh?
Yeah. So now we're going to make a post request to the new order endpoint and provide this with our mini payload. Okay. So it did that as well. That's cool. And now let's do the get to see if it's actually in there. So it's the order endpoint that we're doing. 200 OK, and we scroll down. Yeah, there's the order ID. All right.
The magic of computers. Well, the wonders never cease.
Yeah, this extension is really nice. I really like it. Yeah. And you can do much more complex things, right? Because whenever you get a response back, you can also capture a response in a variable, and then use some kind of a dot notation to get to certain elements in the response and use that as an input for a next call. So it's really quite a powerful thing. All right, so you have the Node application, and it's connected to Redis because we can do like posting and getting of stuff. So that's cool. So we should move on to because this is the curl command which we didn't use. So let's move on to our Python application. So let's say again a separate resource just mentioned here. In this case, only a deployment because we won't be calling into that. It will just be a service running on its own. And doing a loop and calling out to the Node application. But again, we see that Dapr is enabled, it has an ID, and this is the image that's used for the deployment. And the code of the app looks like this. So again, we're not using any Dapr packages in this case. So we have a Dapr URL again, and we just have like a continuous while loop. So while true, we start with n0, we just increment a number, we create a new order ID based on the number, and then we do a post request to the Dapr URL. But this is an important one now. We are specifying a Dapr ID header, and that contains the Dapr service application ID that we saw earlier. And because we do this, Dapr knows where to find our Node application.
So that's sort of like the glue that kind of holds these things together a little bit, right?
Yeah, exactly.
Yeah, okay. Yeah. That would be the sort of thing that you'd want to be probably maintaining in some sort of a project-wide
yes. Yeah. Because
key value store of some type, perhaps.
You don't want like magic strings like this appearing all over. Yeah, exactly.
Yeah, for sure.
Yeah, good call. So that's what it's doing. Like it sleeps a second and then it makes another call. All right.
The nice part about putting sleeps in your code is that if ever you need like to get a raise, or just be like, I increased the performance of our application by 33%.
Exactly. Yeah,
it's nice.
Excellent. I'm learning so much about you, Dan. It's,
Tricks of the trade.
Yeah. All right, so we gave the command to apply the configuration to deploy the Python servers, but let's check if it's already rolled out. Not yet. So let's wait a couple of seconds. but we can already actually start the log of the node application by doing kubectl logs and then select the node app. It's already rolled out, so it will actually be like, seeing all of the outputs of that order IDs are being collected by the node application. So it seems to be working.
That's a first. I mean, of course.
That's amazing. Oh, yes. Yes. Cool stuff. Cool stuff. All right. One of the things I did not show you yet. Okay, we're believing this, right? We can stop this. Okay. Because we didn't show the dashboard yet. Dashboard. So -K takes us to connects to the Kubernetes context. So this dashboard will be running locally. So it's opened up at a different browser window now. So let me pull it back. Oops. So this is the Dapr dashboard that shows you different kind of things. So for instance, you can see, okay, how's the control plane doing? What version of Dapr is running? I've lost your screen, by the way. Let's go back here. Yeah, and you can also drill down for more information, but you can also see what kind of applications are running in there. And in this case, it's quite basic. You only have 2, but if you have more and more applications, this is nice actually to see what's out there. And again, you can do some kind of drill down to see some more information about this and what the actual configuration is used under the hood.
I'm going to go ahead and assume that this is just making API calls under the hood and rendering results,
yeah,
right?
Exactly. Yeah, indeed. Yeah.
Okay, so if I wanted to have this information available to me, not in this particular dashboard, if I wanted to have it available in some other software I was using, if I wanted to ship this off to some sort of observability tooling, that's possible.
That's definitely there. Yeah, because we have one of the building blocks also needs observability. So yeah, if you want to let this go to Prometheus or Grafana or whatever, it's just like a matter of appending a couple of lines to these custom resource definition files to point out where you want your metrics to go to. Yeah, because actually the metrics is not shown in this dashboard, by the way. So this is more about which components you have and the applications you have, and not so much about CPU cycles or memory use or stuff like that. So that is collected, but indeed it's up to you to define where you want to have it go to. But it's definitely part of Dapr.
Well, if you're putting this into some sort of observability tooling, this would be a fairly rich source of metadata.
Yeah, definitely.
Right?
Yeah.
And as you said, it's not the actual metrics. It's not CPU usage or disk or whatever it's going to be, right? But it's the data you need to have in order to make all of that other data contextually sound.
Yeah, exactly. Yeah, and so what we can show you here is, for instance, the logs. So, and this is you can choose, because we have application logs, but also logs of the Dapr process of the Dapr sidecar. So by default, it shows the logs of the Dapr sidecar. And let me zoom in a bit more, so you can see what kind of endpoints are hit. It also does like health checks every couple of seconds. So these are also in there.
That's nice because you're using a structured logging format there, right?
Yeah, exactly.
Which again, if you're watching the stream and you're not familiar with the phrase structured logging format, it sounds very fancy, and there's a lot of observability companies out there that would charge you a ton of money to tell you what that is. All it is you turn your logs into key value pairs.
Yeah,
that's it. I just saved your company €500,000. You're welcome.
Yeah, that's indeed super useful. Yeah. Yeah, so this is useful for like local development or some debugging and stuff, but it's not to monitor your production workload, right? So then you definitely need your decent full-blown observability tools. But yeah, it's easy to set up. And like I mentioned, you can also just look at your application logs as well, so we can see the same stuff happening here as we did in the console.
We are indeed capable of incrementing a counter.
Woohoo! In this case, we're using a state store. So in case you have lots of components and want to see more, okay, what are all the components, what versions of it, how long is it running, etc., you can also get to that information. So the dashboard is a bit minimal, but yeah, we expect everyone to use some kind of observability tool anyway. So that's that. Yeah,
that's pretty cool. All right. Well, we went through a lot of steps there, and maybe if you're kind of looking at this, you're jumping into it the first time, you're thinking, boy, I thought this was going to be easy, but like, look at all these things we had to do, look at all these steps we had to go through.
It is, yeah, exactly. It's not like do these 3 things and you're done. No, it is still quite involved. Yeah, that's definitely true. Yeah.
Well, I think that's true of anything in the world of Kubernetes, though, isn't it? Right?
Yeah, I'm afraid so. I'm afraid so. Yeah, exactly.
Yeah.
Yeah.
But no, but at the end of the day, like there were a couple of logical sort of things going on here, right? So what we started with was, and even before we started typing anything, right? What we started with was trying to understand what are the different moving parts.
Yeah.
Right. We know we're going to be thinking about, we have some application code, we have some backend code, some front-end code. We know we have this Kubernetes we want to use. We know we have a cloud provider that we want to run this stuff in, exactly. Right? Yeah. We know we have Dapr. So we think all these different moving parts. At least we know what they are. We enumerate them. Yeah. We sort them all. We write a little bit of documentation just to help ourselves out, right? To sort out our own thoughts. Mm-hmm. And then, we go, okay, let's start at the beginning, right? And the beginning, the first thing we had to do is make sure we have resources available to us.
Yeah.
Right? You can't run software, in the ether. It has to run on a computer somewhere. So first we made the computer available to us. And we go, okay, we have a computer now. Now we need the environment in which our software is going to run. And so we made that go, right? In the form of the Kubernetes.
Yeah.
And then we go, okay, then we have the actual things we want to deploy. Right?
Yeah, like the state stores and
precisely.
And also the nodes even.
Precisely, the nodes and everything. And then comes, okay, now we actually get to try out this Dapr thing, right? Because now we're in a position where we have resources, we have, the capacity to run code in places and to, store the output and to retrieve data, right? These sort of basic building blocks. We go, okay, so we make the Dapr go, the Dapr goes. And then once that's in place, then we can go on top of that. We actually have application stuff.
Yep.
Right. Yeah. So we really are following a logical set of procedures there. There's nothing that's particularly surprising when we're thinking about how to make software go in the modern era. But just thinking about breaking it down into those sections really helps us to wrap our heads around what appears, when you kind of just say it all at once, to be a long series of steps.
Indeed. Yeah.
Totally agree. Yeah, Kubernetes for me is like information all over the place that I need to somehow learn how to connect. But you have presented this whole process in a step-by-step way that I personally can follow, and hopefully everyone will be able to follow it and get the most out of what you just shared. So yes, thank you.
Excellent.
Yeah, that was excellent. Very, very well executed. So we actually a little bit over time. It's okay. It's Friday, right? It's fine. But I do want to respect everybody's time, people watching the stream, people here on the stream. So we'll wrap it up there for now. Thank you so much for everybody hanging out on the Twitch chat today. It was nice to have some people interacting with us today. That was really fun. Super appreciate that. If you're watching this on the replay afterwards, and we know that there are people who watch us on the replay afterwards, we have those statistics. Thank you to everybody on YouTube watching this afterwards. You can still interact with us. We'd really like that. Hit us up on the community chat. Hit us up on Twitter. We're at Scaleway_devs if you want to get a hold of us. We'll make sure to tweet out Diego's and mine and Mark's Twitter handles. You can want to chat with us directly. If you just want to check out some 8-bit art.
Indeed, yeah.
Right, Mark, you're rad for that. Yeah, for sure. We just had a question actually in the chat from Laurent. Where are the replays on Twitch or on YouTube? So we do have some replays on Twitch. We don't put them all there. And also Twitch times them out, ages them out after a while. But all of the replays are stored on YouTube. We should probably get a playlist going. What do you think, Diego? Yes, the answer is yes. We'll get a playlist going.
Used to streaming from my laptop only. Need my whole setup with my stream deck and all that. Yes, we should. And we could actually create a podcast on YouTube.
We get a podcast?
Yeah. That's a thing.
A pod? Do you mean like an RSS feed?
Yeah.
Okay. Yeah, super. We could definitely do that for sure. But good question, Laurent. Appreciate that. Thank you very much. Okay, so thank you again so much to everybody who participated. Thank you so much to you, Mark, for willing to come on stream and show us some pretty cool stuff. And also thank you to the demo gods for gracing us today.
We were so lucky, yeah.
With functioning infrastructure. Exactly. And as always, check out the replays. Hit us up on the Twitters. Hit us up on the community, the Slack community, and hit us up next time. We're streaming Friday afternoons, and if that changes, we'll let you know. And that's it for us. Thank you so much, everybody. We'll see you next time.
Thank you. Thank you, Mark. Bye, Dan.
Bye.